Let's take a quick look at linear, quadratic, and exponential models and how to tell the difference between those. All right. In the real world, a lot of times you gather data and then you have to decide what kind of relationship it is. The three that we have studied so far will be linear, quadratic, and exponential. Now, how can we tell? One way would be by a graph. Take this data, plot it, and when we see a curve going like this, we say this is exponential. To be more specific, this looks like exponential growth. If we take this data and plot these, this definitely looks linear. It looks like a straight line. And if we take this data and plot it, I'm hoping that you can see a parabola there. So that would make this quadratic. See the parabola going down like this. Okay? So that's one way to tell, is simply by looking at the graphs. Another way to tell is by looking at the relationship of the data itself. We're looking for patterns when it comes to that. Now, just really quickly, remember that with the x value, with your independent variable, we want to have an arithmetic sequence. So we want to have like plus 1, plus 1, plus 1, a constant difference there. Then with our y value, the y value tells us what kind of model that it is. So let's take a look here. In this case, you'll see with your x's, you've got plus 1, plus 1, plus 1. And with your y's, you've got minus 3, minus 3, minus 3, minus 3. So you have a constant change, a constant difference of minus 3. That's an arithmetic sequence. That makes this linear. Okay? So when you have this first difference here, that is linear. For this one, again, with the independent variable, we've got plus 1, plus 1, plus 1, plus 1. And then for my dependent variable, I've got plus 64, plus 32, plus 0, minus 32. If we do that a second time, we end up with minus 32, minus 32, minus 32. This is called your second difference rule, and that makes this quadratic. Okay? And then we've got, in this case, we've got plus 1, plus 1, plus 1. You'll notice that with the x values or your domain or your independent variable, it's the same. It's going to be a constant difference there each time. Here, I didn't have, I could find what added each time, and I could try it again, and it wouldn't work. But there is a constant ratio. I'm multiplying by the same thing over and over again. That is exponential. Okay? So, just to recap here, linear equations are going to look like this. Y equals mx plus b. They're going to be a line, and you're going to have a constant first difference. All right? For quadratic, this is standard form, ax squared plus bx plus c. Your graph will be a parabola. It'll be a constant second difference. And exponential, y equals ab to the x. It's going to be a curve, either a curve going up for exponential growth or a curve going down for exponential decay. You have a constant ratio. Now, take a look at this. It's all about the placement of the x, or something going with the x. Here, the x is very plain, right in line with everything else, linear. Here, you've got an x squared. With quadratics, a, b, and c are real numbers. B and c, it's okay for them to be 0. It's not okay for a to equal 0. Okay, so when this x squared is what makes it quadratic, and here your x is an exponent. And that's just a real quick review of those three models.